Let G be negative x minus 3 squared plus 1. The graph of G is obtained by a reflection of the graph of f in the x-axis, followed by a translation of the vector PQ. C. Find the value of P and of Q. All right, C. Well, the first thing that I can see is that since there's an inside transformation, a horizontal translation, that's what we're going to go after first, right? So what do I have to do inside with x so that x minus 1 becomes x minus 3? I would have to subtract 2, right? So that will become x minus 1 minus 2 squared minus 9. So my new translated f will be x minus 3 squared minus 9. And what just happened was I shifted 2 units to the right. Remember that inside, whatever happens with x happens the other way around. So if I subtract 2, I actually move 2 units to the right. So if I have a vector PQ that represents these translations, then I know that P is going to be 2. All right, now we have to worry about the outside, about the vertical transformations, right? And the first one that I'm going to worry about is this reflection about the x-axis. So I'm going to multiply everything outside by negative 1. And when I do that, I get minus, open brackets, x minus 3 squared plus 9. Okay, so since this is a reflection, it has no, there's no change of my vector. Actually, it doesn't affect my vector, my translation vector. So we're not doing anything. We're just adjusting to what G actually is. And now, what do I have to do to this reflected and translated f in order to make positive 9 become positive 1? Well, I have to subtract outside by 8. So it'll be minus, open bracket, oh, sorry about that. So this will become, I have to subtract outside by 8 units. So it'll become minus, open brackets, x minus 3 squared plus 9 minus 8, which will become 1. So I'll have that minus f of x minus 2 squared, minus f of x minus 2 minus 8 equals minus x minus 3 squared plus 1, which is g of x, right? So I can see that my vertical translation was going down 8 units. D. Find the x-coordinates of the points of intersection of the graphs of f and g. So for this one, basically, all I have to do is equate f of x with g of x, because that's where they're going to intersect, right? So it'll be f of x, which is x minus 1 squared minus 9, must be equal to g of x, which is negative x minus 3 squared plus 1. So we're going to expand both sides, so I get x squared minus 2x plus 1 minus 9 equals to minus, open brackets, this is going to become x squared minus 6x plus 9 plus 1. And if I distribute this negative here, we'll get x squared minus 2x minus 8 on this side equals negative x squared plus 6x minus 9 plus 1. Okay, so this minus 9 plus 1 is going to be negative 8, which I'm going to be able to cancel with this negative 8 over here. So if I send everything to the left, I'll get 2x squared minus 8x equals 0. And I can factor out 2x. That will give us x minus 4 equals 0. So I only have 2 possibilities here for this product to become 0. I have either that x equals 0, because if x equals 0, this whole product will become 0, or I have that x minus 4 equals 0, which would make x be 4. So my solution set would be 0.04, 0.4, and which means that my x coordinates are just x equals 0, x equals 4.